Hi everyone, I hope you're okay, and I really hope that guys the videos we keep uploading and helping you out. Please note that guys, on this video guys, I'll be just focusing on the first three laws, Isaac Newton, and the universal law of gravity will have its own video. Uh, I'll just try to explain deeply the three laws, and obviously spend more time explaining, not explaining rather, spend more time in applying the second law of motion. Okay, before I even start, guys, please do share this video to your peers. A thing or two that I'll mention here might help them. And obviously, please do help us grow the channel by just subscribing. Okay, Newton's first law. Newton's first law. It simply states that a body will remain at rest or continue moving at a constant velocity unless an unbalanced set of forces acts on it. Are we together? A body will remain at rest or continue moving at a constant velocity unless an unbalanced set of forces acts on it. Okay, this law simply says that guys, let's say as you are listening to this video over here, you just put your phone there on top of a table, and you're obviously focusing on you are paying attention to what I'm saying to you now. Newton's first law simply says that your phone will remain on top of the table unless you decide to pick it up. Are we together? Okay, another part of it simply says that if a car rather is moving at a constant speed, it will continue moving at a constant speed unless the driver decides to change the velocity of the car. Are you together? But if the driver does not decide to change the velocity of the car will just just continue moving at a constant speed. Are you together? So the most important thing, guys, you must know about Newton's first law. Newton's first law, F net is always equals to zero. Are you together? Which simply means that yes, there are forces which are acting on the object, but none of those forces overpower one another. All of them are at equilibrium, and hence we have constant motion, or rather objects which are just at rest. Are you together? And then there is this property over here. It's called inertia. Inertia just talks about the tendency of the body to resist its change in motion. Are you together? For example, if you're in a car, maybe you're seated on a passenger seat and the driver decides to hit the brakes. If you did not wear your seatbelt, your body will continue moving towards the right. If the car was moving towards the right as well, né? And then the driver decides to hit the brake, simply means that your body will continue moving towards the right as well. Are you together? That's why there was introduction of our seat belts, just to prevent your body from continuing moving towards the right because of inertia. Are you together? Okay, and then now we have our second law. Second law. Second law simply says now a body will accelerate in the direction of the resultant force, and that acceleration is directly proportional to the resultant force and inversely proportional to the mass of the object. Right together, a body will accelerate in the direction of F net, or you can say resultant force, with an acceleration which is directly proportional to F net and inversely proportional to the mass of the object. So acceleration and F net, they are directly proportional. Then acceleration and the mass are inversely proportional. Are you together? From these two relationships, there was a formula which was then constructed. It says F net is equal to MA. The net resultant force acting on the object is equal to the object's mass and its acceleration. To the product rather of the object's mass and its acceleration. But by definition, what is acceleration? Acceleration is the rate of change of a velocity. Right, together. So which simply means that whenever I calculate my F net, I can simply use the rate of change mass. I can say mass multiplied by the rate of change of a velocity. Out together. But at my numerator, I have mass multiplied by the change in velocity, and that's definitely equals to the change in momentum. Change in momentum, I still have the change in time at my denominator. That's why there is a second, there is an alternative definition, or rather, there is an alternative definition of Newton's second law, especially for those who are doing grade 12, because they deal with the momentum and impulse. So you can simply say that the net resultant force acting on the object is equals to the object's change in is equal to the object's rate of change of momentum. Together, the net resultant force acting on an object is equal to the object's rate of change of momentum. That's the alternative way to state the law, né? Okay, we'll come back to the second law because all the calculations are basically based on the second law. And then now we have our third law, which simply states that if body A exerts a force on body B will exert an equal but opposite force on body A. I do have a typical example for this law. I do have a nephew of mine who loves soccer. If he decides to kick this ball towards the right, the magnitude of the force that his foot will exert on the ball is the same magnitude rather the ball will exert on the foot. Are you together? That's why soccer players use soccer boots, so that whenever they kick the ball, their feet do not hurt. Are you together? Because the same force they apply to kick the ball, they will experience the same force due to the ball, and hence their foot will be painful. And then there was an introduction of using soccer boots. Back then, the soccer boots had sponges because the soccer balls were much more firmer. But now soccer balls have sponges, so you wouldn't feel too much pain whenever you kick a soccer ball. Are you together? However, body A will exert a force on body B, and body B will exert an equal but opposite force on body A. Okay, now let's just do these examples. Let's apply our knowledge. We are told that a force of 200 Newton is applied to push the 50 kg box to the right. The magnitude of the kinetic friction on the box is 10 newtons. The first question, they want us to draw a labeled free body diagram showing all the forces acting on the box. Okay, our box is in the universe, so our box will definitely experience a gravitational force, or usually called a weight. Are you together? Secondly, our box is on top of a surface, so it will have a normal force. Normal force is just a contact force, guys, which is always perpendicular to the surface. Always perpendicular to the surface, né? The force which is applied is pushing our box towards the right. So we have our applied force over here, which is just 200 newtons. And then we have our kinetic friction, which always opposes the motion. The kinetic friction, guys, always opposes the motion of the object. Are you together? Please don't make a mistake and say frictional force it always opposes applied force. That's not true. Frictional force always opposes motion. Okay. And then now they want us to calculate the average net force exerted on the box. Please note that, guys, our box is being pushed towards the right, and it will only accelerate horizontally. So since there is no vertical acceleration, it simply means that the vertical forces are at equilibrium. Are you together? Being at equilibrium simply means that they are both equal to one another. Hence, they will cancel one another and there will be no vertical acceleration. So the only acceleration that will take place here will be the horizontal acceleration. Yeah? And secondly, whenever you deal with calculations in Newton's laws, it's very, very important to choose a positive direction. Are you together? Word of advice, please always choose the direction of motion as positive to avoid making mistakes. Né? Always choose the direction of motion as positive. So in this case, our box is being pushed towards the right. So any movement towards the right hand side has to be positive. Okay, so now let me go and calculate my F net. F net by definition is just the sum of all the forces in one dimension. On my horizontal dimension, I have my applied force plus my frictional force. The frictional force is negative because friction is opposing the direction of motion. Okay, I'll simply have 200 plus a negative 10. This will give me 190 newtons to the right. Remember that, guys, force is a vector quantity. If they say to you calculate the net force, not the magnitude, they just said calculate the average net force. That means I must give the magnitude and the direction as well, because I'm calculating a vector quantity. It's very, very important to have both magnitude and direction. Okay, secondly, they want us to calculate the acceleration of the box. Remember that F net is equals to ma. I do have my net resultant force before I even calculate. Since my F net is positive, I'm expecting to find a positive acceleration. Why? Because a body will always accelerate in the direction of the resultant force. If my resultant force is to the right, my acceleration has to be to the right as well. So I do know that my F net is equal to 190 newtons. The mass of the object of the box is 50 multiplied by A. If I divide both sides by 50, what do I get? 190 divided by 50. I'll simply get an acceleration of 3.8 meters per second squared towards the right hand side. That's how, guys, we deal with these simple questions. Are you together? But please note that on this video I'll just do 5 exercises, né? And all of them, guys, I build up the first 4 exercises rather are the build up to the last question. The last question is the most important one, but I'm just taking you gradually for you to be able to answer those types of questions. Okay, let's do the second exercise. We are told that a force of 200 Newton is applied on the box to pull a 50 kg box on a rough horizontal surface. The coefficient of the kinetic friction between the box and the surface is 0.02. The first question, they want us to draw a labeled free body diagram showing all the forces acting on the 50 kg block. Our box is in the universe, so it will always experience a gravitational force which is always acting vertically downwards. Gravitational force, since our object is on top of a surface, it will always experience a normal force, which is a contact force that is always perpendicular. to the surface, and we do have our applied force which pulls the box towards the right. Force applied, which is just 200 newtons, and then we have our kinetic friction. We have our kinetic friction, which will always oppose the motion. Okay, they want us to calculate the magnitude of the kinetic friction. Remember that you are not given the value of the kinetic friction, however we are given its coefficient. There is a formula we use to calculate kinetic friction. It's mu k multiplied by the normal force. Mu k is just the coefficient, and then we can find the normal force. Remember that, guys, our box is not accelerating vertically, which simply means that the vertical forces are at equilibrium. With that being said, I can therefore conclude that my normal force will be equals to the gravitational force. Are you together? So normal force will be equal to gravitational force, right? But gravitational force is mass multiplied by gravity. That's 50 multiplied by 9.8. What do I get? 50 by 9.8. I'll simply get 490 newtons, 490. So that will be the magnitude of my normal force, right? So for me to calculate frictional force, I'll simply take the coefficient. It was 0.202 multiplied by 490. This will simply give me 9.8 newtons. 9.8 newtons, nah? Okay, now I do know the magnitude of the kinetic friction. I can simply calculate the acceleration on the following question. For me to find acceleration, I'll simply use the formula that says F net is equal to ma, right? F net is just sum of all the forces in one dimension. So in our horizontal dimension, we only have two forces. We have our applied force plus the negative kinetic friction. Are you together? Our friction is negative. Why? Because friction is opposing our motion. This is equal to ma. It will be 200 plus a negative 9.8 is equals to 50a. This will give us 190.2 is equals to 50a. Whenever I divide both sides by 50, 190.2 divided by 50, this will give me 3.804 meters per second squared towards the right. Towards the right. So that's how we deal with acceleration, nah? And then now let's go to question 3. Okay, we are told that a force of 150 newtons is applied to pull the box to the right at an angle of 20 degrees with the horizontal. The magnitude of the kinetic frictional force between the box and the rough horizontal surface is 15 newtons. The first question, they want us to draw a labeled free body diagram showing all the forces acting on the 60 kg block. Our box is in the universe, so it will experience gravitational force, né? It will experience the weight, and our box is also on top of a surface. It will also experience normal force. We do have our frictional force, which opposes the motion. So I'll simply say friction over here, and then we do have our applied force, which is applied at an angle. F applied, which is just equals to 150 newtons. You can indicate the angle if you want to, 20 degrees. But there is another way, guys, to draw this free body diagram. Remember that, guys, yes, our applied force is applied at an angle. However, the box is moving horizontally. Hence, we will use the components of this force because our force is accelerating horizontally. So the components of this applied force are only two. We'll simply have a horizontal component and also a vertical component. Let me draw the alternative free body diagram over here. We do have our gravitational force, our frictional force, our normal force, and then now we have the components of the applied force rather. It has the horizontal component as well as the vertical component. Our horizontal component, we can call it Fx. This will be equal to the magnitude of the force multiplied by cos theta, where theta just represents the angle of inclination between the force in question and the horizontal surface. So theta will be equal to 20 degrees. Are we together? So, and then we also have our vertical component. Excuse me. Vertical component is equal to the force in question multiplied by sine theta, where theta represents the angle of inclination between the force in question and the horizontal surface. Are you together? So you can either draw your free body diagram like this or like that. You'll simply get your full 4 marks. Okay, and then now they want us to calculate the magnitude of the acceleration of the box. Remember that, guys, our box is not accelerating vertical. So we must only focus on the horizontal forces that we have to calculate acceleration. These are the only horizontal forces we have. So we can simply say F net is equals to MA. We have our horizontal component plus negative kinetic friction. Why is it negative? It is opposing the motion. This has to be equals to MA. With Fx, remember that, guys, we just take the magnitude of the force multiplied by cos theta. We'll just take 150 cos of 20 degrees minus frictional force. We're told that it's 15 newtons. This is equals to 60 A. Are you together? So A is just 150 cos 20 minus 15 all divided by 60. This will give me 2.099, which can be written as 2.10 meters per second squared towards the right. That's how you find the acceleration, guys. This question was very important because I wanted to show you how to deal with forces which are applied at an angle. On exercise number 4, I want to show you how to calculate a frictional force whenever you are given applied force at an angle. It's very, very important. Okay, we are told that a force of 150 newtons is applied to pull a box at an angle of 25 degrees to the horizontal. The coefficient of kinetic friction between the rough surface and the box is 0.03. Excuse me. Draw a labeled free body diagram showing all the forces acting on the 50 kg box. The free body diagram will be like this. You do have your gravitational force, your weight over here, your kinetic friction, which always opposes motion, your normal force together, and also the applied force. 150 newtons. You can indicate the angle if you want to, 25 degrees. Or instead of using the force, the applied force at an angle, you can simply use the components of the force. You'll draw a free body diagram like this. You'll have weight, you'll have friction, Fk, you'll have your normal force, and then the components of this applied force. It has both the horizontal component and the vertical component. Ne? Horizontal component is the force in question multiplied by cos theta, where theta is equal to the angle of inclination between the force in question and the horizontal surface. Same thing applies with the vertical component. It's the force in question multiplied by your sine theta, where theta is the angle of inclination between the force and the rough surface. Are you together? Okay, so now they want us to calculate the magnitude of the kinetic friction. Remember that, guys, kinetic friction is equals to mu k multiplied by normal force. Ne? But in this case, guys, we cannot say normal force is equal to the gravitational force. Why? Because we have a force which was applied at an angle. So we have more than two vertical forces. Are you together? Yes, our box is not accelerating vertically, but we do have more than two forces vertically. Are you together? So if we calculate F net for the vertical forces, yes, F net is equal to 0 because there are no forces, because rather our box is not accelerating vertically. So we can simply say normal force plus the vertical component of the applied force minus a gravitational force is equals to 0. Why am I subtracting gravitational force? Because gravitational force is always opposing, because gravitational force rather is acting on a different direction as the other two forces. So in normal force is simply equals to a gravitational force minus the vertical component. Are you together? So in here I can simply say the coefficient multiplied by weight minus the vertical component. Are you together? I was given the coefficient to be equal to 0.03. For me to calculate weight, I just need the mass of the object. The mass is 50 kg multiplied by 9.8 minus the vertical component, that's 150 sine 20. It's sine 25 rather. Let me fix that. Sine 25. This will give me a frictional force. Now, simply say 0.03 multiplied by 50 times 9.8 minus 150 sine 25 degrees. This will give me 12.80 newtons. So my kinetic friction is just 12.8 newtons now. So whenever, guys, we are given a coefficient of friction and we have our applied force, which is applied at an angle, for us to find a normal force, we just need to take the gravitational force and subtract it to the vertical component of that force, of the applied force. That's how we can find the normal force. Né? Okay, third question, they want us to calculate the magnitude of the acceleration of the box. Remember that F net is equals to ma. Are we together? But since our box is only accelerating horizontally, we will focus on the horizontal forces. We simply have Fx plus a negative kinetic friction being equals to MA. Are you together? So Fx is just the magnitude of the applied force multiplied by the cos of the angle of inclination minus 12.8 is equals to 50A. So our acceleration is just equals to 150 cos 25 minus 12.8 all over 50. This will give me an acceleration of 2.46 meters per second squared towards the right. Are you together? So that's how, guys, you deal with forces which are applied at an angle and when you are given a coefficient of friction. Now let's do the last question. All these questions, guys, were just a build up to this question. I know that now you'll find it easier to tackle this question because of the previous work. Let's just get right into it. A light inelastic string connects two objects of mass 8 kg and 4 kg respectively. They are pulled on a rough horizontal surface with a force of magnitude F, which is applied at an angle of 20 degrees to the horizontal. We must calculate the mass of the we must ignore the mass of the string, né? And then we are told that the coefficient of friction is the coefficient of friction for the 8 kg and the 4 kg block is 0.2 and 0.1 respectively. Okay, we must draw a labeled free body diagram indicating all the forces acting indicating all the forces acting on the 4 kg block. Okay, the free body diagram indicating showing all the forces acting on the 4 kg block. Né? Our 4 kg block is in the universe. It will always experience a gravitational force. And gravity, guys, is always vertically downwards. Always the time. Né? Our box is on top of a surface. We do have our normal force. No, that's too much. Yeah. We do have our normal force now. And then there is a frictional force which opposes motion. And then we do have our applied force which is acting at an angle F applied. And remember that, guys, there is a tension which is connecting the two boxes. There's tension over there. The tension on the string. Né? You can draw a free body diagram like this and get full marks. Kudos. You can indicate the angle if you want to as well. That's 20 degrees. But I will always prefer to draw a free body diagram that has the components of the applied force which is applied at an angle. Né? I'll simply have my weight. I have tension as well. Excuse me. I have my kinetic friction. I have my normal force. And then I have the components of my applied force. Ne? The first component is the horizontal component Fx. Ne? Fx is just equals to F cos theta. And then we do have our vertical component as well. That's F sine theta. Okay, then now they want us to calculate the magnitude of the kinetic friction on the 8 kg block. Remember that you are given a coefficient of friction. Ne? If you can draw a free body diagram for the 8 kg block, 8 8 kg block will be pulled by the tension on the string, and yes, there is a frictional force acting on the 8 kg block. We also have our weight and the normal force. Are you together? So since there are only two vertical forces, we can conclude that this guy over here is equals to that one. Normal force is equals to weight, because there are only two forces on the vertical dimension rather. So for us to find the kinetic friction, we need to say mu k multiplied by the normal force. This is the coefficient of friction. The coefficient is equals to 0. For the 8 kg block is 0.2. Are you together? And then, but the normal force, remember that, guys, the normal force is equals to gravitational force only on the 8 kg block. Why? Because there are no forces which are applied at an angle on the 8 kg block. So since gravity is equal to normal force, for me to find the normal force, I'll simply take the mass, which is 8 kg, multiplied by the gravitational acceleration. So this will give me the value of my frictional force, 0.2 multiplied by 8 multiplied by 9.8. This gives me the value of 15.68 newtons. This is the value of my kinetic frictional force. Okay. And then the third question, they want us to calculate the magnitude of force F if the two boxes are moving at a constant speed. If the two boxes are moving at a constant speed. Constant speed simply means that F net is equals to 0. Are you together? So we have our 8 kg and the 4 kg block. For the 8 kg, there are only two forces which are acting horizontally. So I know that F net is equals to MA. I need to write that first. And then I know that I have my tension, which is acting in the positive direction, and friction, which is acting in the negative direction. This is equal to 8 multiplied by 0. Remember that the system is moving at a constant speed. Constant speed simply means there's zero acceleration. Are you together? So tension minus 15.68 has to be equals to 0. That means tension is equals to 15.68 newtons. Are you together? It's very important for me to find the tension, because I will use it on the other side for me to find the value of the magnitude of a force F. Okay. For the 4 kg block, I know that F net is also equals to MA, right? How many forces are there horizontal on the 4 kg block? I have 3 forces: the horizontal component, kinetic friction, and the tension. Are you together? So it will be horizontal component plus the negative tension and the negative friction is equals to 4 multiplied by 0. One may ask, okay, why is tension positive on one side and negative on the other side? Guys, tension is just an action-reaction force. The same amount of force that the 4 kg applies on the 8 kg is the same amount of force that the 8 kg applies on the 4 kg, but in different directions. Are you together? So the string is trying to pull the 4 kg block towards the left, and the string is also pulling the 8 kg block towards the right. Are you together? Pulling the 4 kg towards the left and the 8 kg towards the right. Are you together, guys? So that's why on one side it's positive and on the other side is negative. The horizontal component is simply f multiplied by the cos of theta, right? Theta is equals to 20 degrees. F cos theta, I do have my tension, that's 15.68 minus frictional force. How can I get a frictional force? Okay, I know that frictional force, guys, I'm coming back here, ne? Frictional force is simply equals to the coefficient multiplied by normal force, ne? But now we have an applied force, which we have our force which is applied at an angle. So normal force is not equal to gravity. Are you together? So for us to find the normal force, we just need to take the coefficient, take the weight multiplied by, and then subtract the vertical component rather. That's how we'll find our normal force if we have a force that is applied at an angle. So in magnitude of frictional force here too, we simply have 0.1 as our coefficient. Let me go and confirm. Yes, it is 0.1. I have 4 multiplied by 9.8 minus the vertical component is just f sine 20 degrees. So this is just equals to 0.1 times 4 times 9.8. This will give us 3.92 minus 0.1 times sine 20 degrees multiplied by f. So this is the magnitude of a kinetic friction. That's the magnitude of a kinetic friction. Yeah? So we'll just substitute it over there. Let me do this. Remember that I said the horizontal component is f cos of 20 degrees minus the tension, that's 15.68, and then we have frictional force here too. Our friction is just negative 3.92 minus 0.1 sine of 20 degrees multiplied by f. This is equals to 0. Remember that on the right hand side, guys, we have 0, né? Because our system is moving at a constant speed. Okay, let me just remove the brackets. I'll simply have f cos theta minus 15.68 minus 3.92 plus 0.1 sine 20 degrees multiplied by f is equals to 0. I have negative 15.68 minus 3.92. This will give me 19.6. So I have f cos 20 plus 0.1 sine 20 multiplied by f is equals to 19.6. Are we together? And then I can take out a common factor here, which is f. I'll simply have f cos 20 degrees plus 0.1 sine 20 is equals to 19.6. So for me to calculate the magnitude of a force F, I need to say 19.6 all over cos 20 degrees plus 0.1 sine 20 degrees. This will give me the magnitude of F. 19.6 divided by cos 20 plus 0.1 sine 20. This will give me 20.13 newtons. So the magnitude of force F, guys, is just equals to 20.13 newtons. I really hope that, guys, this video helped you out. Please note that, guys, the following video we're just tackling questions whereby I'm dealing with inclined surfaces, and then the third video will be on pulleys, and then the fourth video I'll be doing the universal law of gravity. Just stay tuned, guys, and wait for more videos. Thank you for your time. Don't forget to subscribe. Bye.